So again, we're looking for this belly probability, 0.985. So we start at 2.10, 11, 12, 13, 14, 15, 16, 17. So this belly probability corresponds to 2.17. So if we know Z, we can find X. Okay? What is the formula? The formula is mu plus Z times sigma square root of n. Okay? So what is mu? Mu is given as 1 in the question. Z, we just found Z, 2.17. We need sigma. Sigma is given also in the question, 0.01 divided by square root of 25. I don't know what this is, so you can probably calculate this. Okay. So we have found the upper control limit. Let's find the lower control limit. So the lower control limit has this tail probability here, 0.015. The corresponding Z value here will also have the same tail probability, okay? Same tail probability, 0.015. From here to here, same tail probability. And we don't even have to look this up because these two tails have the same tail probability. So if this is 2.17, this should be minus 2.17, just by symmetry. So let's use the same formula, lower control limit, mu plus Z times sigma, square root of n. Mu is 1. Okay, mu is 1 given. Plus minus 2.17 times sigma is 0.01 divided by square root of 25, and whatever this is. Okay? So, does this make sense to everybody? Any questions? Okay. So let's go to part B. As you can see, part B is crossed out here. Part B is crossed out. So that means don't worry about this question. It's not going to be on the exam. Okay, so if a question is crossed out, then don't worry about it. Okay. So let's go to question number 3. Okay. So question number 3. Erase this. So in question number 3, they are measuring checkout times at the supermarket. Okay, and they are using a mean control chart and a range control chart. Okay. So they take 6 samples okay? And each sample has 20 items in it. Sample size, 20 items. Okay? So, using the factors in table 10.3, determine the upper and lower control limits for the mean and range charts. So basically, we're looking at the following formulas. Okay. Mean control chart and range control chart. Okay. So let me write down the formulas. So for the mean control chart, lower control limit, upper control limit, x double bar, plus, minus plus, lower is minus plus, A2, R bar, okay? And so let's look at the question. Okay. So this is x1 bar, okay? So this is the average of the first sample. This is the average of the second sample, average of the third sample, fourth sample, fifth sample, and sixth sample, okay? And this is the range of the first sample, R1, R2, R3, R4, R5, R6. Okay. So, can I have one of those solutions? Thank you. Okay. So basically, we need to find x bar, x double bar. X double bar is the average of these numbers. Okay? X double bar is the average, okay? And the average will be 3.108. So these are sample averages or sample means. And when we take the average of sample means, we get x double bar. So we average these to get this. Okay. So we have found x double bar. Now let's find R bar. R bar is the average of these ranges, and it is 0.45. Okay, so now we can plug these in. So 3.108, 3.108 minus plus, we don't know A2 yet, so 0.45, 0.45. Okay. So the only thing we need to find now is A2. Okay, A2 is given in a table on the back of your formula sheet. Okay, so these factors for the control chart, You see A2 is there, okay? Now, which A2 are we going to use? That depends on the sample size. The question said our sample size was 20, okay? Since our sample size is 20, we're going to use this A2, okay? So it's going to be 0.18. And then, when I plug in everything, what do I get? 3.181, and I get 3. So these are the upper and lower control limits of mean control chart. Okay. Is everybody clear so far? So let's do the range control chart. Okay. The formula for the range control chart is as follows: D3 times R bar, D4 times R bar. Okay. So we already calculated R bar. Okay, R bar is this here. All we need to do is find D3 and D4. These are also given in this table. So D3 is 0.42, D4 is 1.57. So 0.42, 1.57, 959 times 0.45, 0.45. Okay, so that gives us 0.189 and 0.716. Okay, so question, yeah.
Yeah, so for the upper control limit, for the mean control chart, it should be 3.189.
Yes.
Yeah. So.
Oh, this is wrong? Upper control limit?
Yeah, so we think that the answer should be 3.189 instead of 3.181.
Okay, 1 second. Oh, okay. Okay,
Maybe
so
it's a rounding or something. I don't know if it's a rounding or.
yeah, it's probably rounded. That's fine.
Okay.
As long as it's close, that's fine.
Okay, thank you.
Okay. So let's go to the next question. So the next question says, okay. So I'm skipping part B because it's crossed out. So let's look at, okay. So computer upgrades have a nominal time of 80 minutes, okay? Now this information is not necessary, okay? This information is given to confuse you, okay? Then samples of 5 observations each have been taken, okay? And the results are listed using factors from this particular table. to determine the upper and lower control limits of mean and range charts. So we're going to use exactly the same formulas. Okay. So I actually, I think it would be easier for me to show you guys the solution to this. Okay. So, okay. Is my cell phone? No. Okay, good. All right. So here, let me write down the formulas again. So this is for the mean control chart, upper control limit, lower control limit, x double bar, plus minus A2, R bar, okay? And for the range control chart, we have the following. So upper control limit, lower control limit, B4, this is going to be B3, R bar, and R bar. Okay. So let's find x double bar. Okay. To find x double bar, I need to find the sample means. Okay. So I take the average of the first sample. So this will be x1 bar, average of the first sample. This will be x2 bar, average of the second sample, average of the third sample, average of the fourth sample, average of the fifth sample, average of the sixth sample. Okay? So these are sample averages. To calculate x double bar, I need to average these. Okay? So I take the average of these, okay, and that's going to be x double bar. Okay, so 79.48 plus 80.14 plus this, etc. And x double bar will be 79.98. So is everybody clear how I found x double bar? I first calculated individual sample means, and then I took the average of the sample means. Okay. So then, let's find R bar. To find R bar, we need the range of the first sample, range of the second sample, range of the third sample, fourth sample, fifth sample, and sixth sample. So to find these ranges, we find the maximum and the minimum. So in the first sample, the largest observation is 81. That's the maximum. And the smallest observation, the minimum, is 78.4. And I take the difference, 81 minus 98.4, gives me the range of the first sample. And then I move on to the second sample. Largest observation in the second sample minus smallest observation in the second sample gives me the range for the second sample. And then I move on to the third sample, largest, maximum, smallest, minimum. The difference is the range. So for each sample, I find the largest observation and the smallest observation, and I take the difference. That gives me the range of each sample. And then, to find R bar, I take the average of these sample ranges, okay? So R bar will be the average. So R bar will be 1.87. So we have found X double bar, we have found R bar, okay? So all we need is A2, D3, and D4. Okay? So for that, we need the sample size. Okay. So the sample size is 5. The sample size is 5. Why? Because there are 5 observations in each sample. Sample size is not 6. Sample size is 5 because there are 5 observations in each sample. So we look up the table here, we find 5. Okay. 5, okay. So for A2, we need to use 0.58. For D3, it's going to be 0. For D4, 2.11. So now we know everything that we know A2, we know D3, we know D4. Okay. So, would you like me to explain this further? Okay. So, let's go to question 5. Question 5 is about a P-chart. Okay. So, using samples of 200 credit card statements, an auditor found the following. Okay. So, they took 4 samples. Okay. They say they have 1 million credit card statements. They cannot inspect each one of the 1 million credit card statements. So they took a random sample. So here, n equals 200, here n equals 200, here n equals 200, here n equals 200. So determine the fraction defective in each sample. Okay, that's fairly easy. Here, 4 divided by 200. Here, 2 divided by 200. Here, 5 divided by 200. Here, 9 divided by 200. Okay? So this is what fraction of each sample has defective credit card statements. Okay. Now, why are there more defective items in some samples and why are there fewer defective items in other samples? Because you take them at random. Okay? You take them at random. So by chance, maybe you took a relatively good sample and then you have fewer defective items, and maybe, again by chance, you picked a lower quality sample and you have more defective credit card statements, just by chance. Okay? So here, so if we look at percentages, this is 2%, this is 1%, this is 2.5%, this is 4.5%. Okay? These are the fractions defective. Okay? Some samples have lower defective percentages, some have higher defective percentages, just because of random sampling. So if the true fraction defective for this process is unknown, okay? So we don't know exactly what percent of 1 million credit card statements is defective, okay? What would your best guess be? So if I said, I estimate that in 1 million credit card statements, 10% of them are defective. Do you think this would be a good estimate? No. Why not? Because this is way higher than these numbers. Okay? So if I said, all right, maybe only 1% of all credit card statements are defective, if I said this, would this be a good estimate? No, because this is way too low. So the true percentage lies somewhere in between these numbers. Okay? Somewhere in between these numbers. So what should our best guess be if we have these percentages? We take the average, right? So I will call this P, okay? So it's asking for the mean and standard deviation of the sampling distributions, okay? So for part B, I'm going to try to see where to write, okay? So I take the average of these percentages, okay? So this is going to be my P, okay? 2% plus 1% plus 2.5% plus 4.5%, okay? Divided by 4 will give me 2.5% or 0.025. Most likely, the percentages, the true percentage is somewhere in between. Okay? So, what is your estimate of mean and standard deviation? For this, we need to use the following formula. Okay? So this is a P chart because you have an item that is defective or not defective. So a credit card statement contains mistakes or no mistakes. It's 0 or 1. Okay? So here, the p-value is the number of total items, and you have number of defective items. Okay, so let's do that. We had the so we had 4 plus 2 plus 5 plus 9 divided by 800. So we had 4 samples. Each sample has 200 items in it, so we have a total of 800 items. How many of these are defective? In the first sample, we have 4 defective. In the second sample, we have 2 defective. In the third sample, we have 5 defective. In the fourth sample, we have 9 defective. And when you calculate this, you get 0.025 or 2.5%. So again, how many items are there in total? 800. How many defective items